Let's look at the basic character of amines in this video. Before looking at the amines basic character, let's understand what are amines first. Yes, as we all know, amines are nothing but the derivatives of ammonia. Yes, this is an ammonia, and amines are nothing but the derivatives of the ammonia. That means if one or two or three hydrogens of this ammonia are replaced by alkyl or aryl groups, then they are called as amines. Right? If the hydrogens which are present in nitrogen, if all or one or two are replaced by alkyl or aryl groups, then they're called as amines. Right. So if you look at this methylamine, that means one of these hydrogens are replaced by alkyl group. These are called as primary amines. If two are replaced, this is two are replaced diethylamine. If two hydrogens are replaced, then they're called as secondary amines. If all the three are replaced, then they're called as tertiary amines. These are aliphatic amines because the hydrogens are replaced by alkyl groups. And for example, if you take aniline, the hydrogen is replaced by aryl group here, aryl group, then they are called as what? Aromatic amines. Right. So they can be primary, secondary, or tertiary amines depending upon the number of the hydrogens which are replaced in ammonia. If one is replaced, then they're called as primary amines. If two are replaced, then they're called as secondary amines. If three are replaced, then they're called as tertiary amines. Yes. And because of the presence of lone pair of electrons on these amines, for example, I'm taking this primary amines, because of this presence of lone pair of electrons on this nitrogen, and also there is electronegativity difference in between nitrogen and hydrogen, which are making these amines reactive here. Right. They're acting as what? Nucleophiles. Because of what? Lone pair of electrons which are present on this nitrogen. In other words, they are acting, they are basic in nature, right? What is basicity? Basicity is nothing but the ability to donate the electrons or ability to accept the protons. Either way, it can be defined, right? The ability to donate the electrons or accept the protons here. Right. So the number of hydrogens differ in primary, secondary, and tertiary amines. Therefore, the reactivity is also different because based on the number of the hydrogen atoms again, right? Here, as the number of the hydrogen atoms are differing here, which decides the course of the reactions here, right? So the reactivity of primary, secondary, and tertiary amines are different here. Right. So we just now discussed that the presence of lone pair of electrons on nitrogen is making them basic in nature. So these are bases, so react with acids, resulting in the formation of salts. So this amine reacts with acid. This is a salt which is formed. This is aniline aromatic amine, which is a base, acid, and this anilinium chloride, which is a salt. Right. And when we look at the pKb values of this, we can understand the basicity, because we all know that pKb, that is inversely proportional to the basicity. The pKb is nothing but the measure of the basicity. The lower the pKb, the higher the basicity, because it's inversely proportional. I wrote here. So the lower the pKb, the higher the basic nature of this, right? When we look at this set of amines, that is primary, secondary, and tertiary amines, so where here R is methyl group. So CH3NH2, that is primary. CH3 taken twice, NH, this is secondary, that is N-methyl methanamine, and CH3 taken thrice, and this is N-dimethyl methanamine. If you look at the pKb, these are the set of values for alkyl substituted, that methyl substituted amines. And if you look at them based on this pKb values, secondary is more basic than primary, than tertiary. Right. When ethyl substituted amines, these are the ethyl substituted amines where hydrogens are replaced by ethyl group here. So when we look at them, the big pKb values, we can come to the conclusion that here these are the three set of values. Here secondary again is more basic, then tertiary, then comes primary. Yes, if you look at them, there is no particular order which is followed in the basicity, right? So, and this benzenamine, which is nothing but an aryl amine, this is aniline here. So H is substituted by aryl group, this is 9.38. And for ammonia, the basicity is, the pKb value is 4.75. These are aliphatic amines with range of how much it is around, yes, if you look at it, the range is 3 to 4.22. That means based on this pKb values, we can definitely say that aliphatic amines are more basic than ammonia, right? What are these? Aliphatic amines are more basic than ammonia, and this aromatic amine, that is aniline, is less basic than ammonia, right? So aniline. This is a basicity order which is followed, and let's look at how we can explain the basicity here based on the different effects. So what are the factors which are affecting the basicity of amines or the basic strength of amines? It's not only the inductive effect, that it's the solvation effect, and the steric hindrance will also come into play, and the all these three act together in deciding the strength of the amines here, basic strength of the amines, right? So based on the inductive effect, we can explain that this is ammonia, right? So this is an amine. I'm taking a primary amine here, where H is being substituted by R here, right? So what is the basicity? Its ability to donate the electrons which are present on nitrogen, right? The more easily it can donate the electrons, the more basic it is, right? So what am I telling is, the more easily it can donate the electrons, or more happily it can donate the electrons, the more basic it is. So in which it is able to donate the electrons easily? Definitely amines, because if you look at it, what is R here? Electron releasing group or donating group. Because here, because of plus I effect, alkyl groups are plus I effect. We know that means electron donating groups, they will donate the electrons towards the nitrogen here, right? They can donate the electrons towards the nitrogen here. So this will increase the electron density on the nitrogen. If it is able to increase the electron density on nitrogen, this will able to donate the electrons easily now, because electron density is more on this when compared to this nitrogen in ammonia, because of the electron releasing effect of this R group, right? So why it is more? Because of the electron releasing effect of R group, the availability of electrons on nitrogen is more, therefore it can more easily donate the electrons here, right? So based on this, we can say that amines are more basic than ammonia. And we can also explain this based on the stability of the ion which is formed, the cation, right? See, the substituted cation is more stable because the positive charge on this nitrogen is stabilized by the R group. Because of what? Electron donating group of donating capacity of this R group, it is able to share the positive charge on this nitrogen, right? It will share, or it will decrease the positive charge, thereby making the cation more stable. But when we look at this ammonium ion, there is no such effect, because there are all the hydrogens which are present. So this is more stable. That means this cation, which is substituted cation, is more stable than ammonium ion. So based on the stability also, we can say that amines are basic than ammonia, right? So based on this inductive effect, what should be the order of the basicity of amines now, right? See, these are the aliphatic amines. If the number of the R groups increases, the more easily this nitrogen can donate the electrons, right? The more easily this nitrogen can donate the electrons. So the order of the basicity based on the inductive effect should be tertiary, should be more basic, then secondary, then primary, because it is increasing the electron density on the nitrogen, right? So it should increase with the increase in the number of the alkyl groups, right? This is correct. Where? In gaseous phase. Okay, so this is order which is followed in the gaseous phase. No problem here, because there's only inductive effect which is playing here. That means based on the electron releasing effect of this R group, that increases the electron density on this nitrogen, thereby increasing the basicity, right? This is the expected order, and this is followed in the gaseous phase. But in aqueous phase, what is happening? So other than the inductive effect, there is also other effects, that is solvation effect and the steric hindrance. Let's look at what is the solvation effect, right? See, okay, here this is a substituted cation, right? Suppose this is a substituted ammonium cations. Right. The more stable the cations, we also read this. The more stable the cations, the more basic the corresponding amine. Right. So here it is the cations are made stabilized by means of what? Solvation effect with water molecules. That means they're able to form hydrogen bonding with water. But there is something which is to be learned here. The greater the size of the ion, lesser will be the solvation effect and less stabilized is the ion. So the smaller the ion, the greater the stability. So if only one substituent is present, the greater its stability because more solvation effect here. So more solvation effect here because smaller the ion. Right. So according to this solvation effect, primary should be more stable than secondary, then tertiary. And based on the stability of these cations, we can say that the primary amines are more basic than secondary, then tertiary. This is just opposite to that of the inductive effect. In that inductive effect, what is that we have seen that tertiary amines are more basic than secondary than primary. But according to the solvation effect, what is the order? Primary should be more than secondary because than tertiary. Because here we are saying that the smaller the size of the cation, the greater is the solvation effect. Because the more easily it can form the hydrogen bonding. Because there are 3 hydrogens here only 2, here no hydrogens in tertiary. So if there are 3 hydrogens, so more hydrogen bonding in secondary, 2 hydrogens, less, just less than that of the primary. In tertiary, there is no hydrogen bonding, no hydrogens and no hydrogen bonding. Only 1 hydrogen and so very less hydrogen bonding here. Right. So based on the solvation effect, the primary should be more basic than secondary, then tertiary. Based on the inductive effect, tertiary should be more basic than secondary, then primary. There is also another effect, which is a steric hindrance, which is coming into play here. So what is this? See, now if I'm changing the alkyl group from methyl to the ethyl group, what is happening? See, there is steric hindrance which is coming into play because the R group is increasing in size here, right? Increasing in size. So if I look at this R group here, for example, yes, this is the cation which is being formed here. Yeah. So if the alkyl group is bigger in size, what happens? There is a steric hindrance. So there is hindrance for the formation of the hydrogen bonding. Right? When alkyl groups is smaller, there is no hindrance here. Yeah, like CH3 group, there is no hindrance. But alkyl group is bigger. That means it changed from CH3 to C2H5, the steric hindrance to hydrogen bonding. Right? So that's all 3 effects will come into play. What are those? Inductive effect, solvation effect, and steric hindrance will decide the basic strength of alkyl amines. So based on all the 3 effects, this is the order of the stability. That is the order of the basicity. That means based on what? Inductive effect, solvation effect, and steric effect. This is the strength. The order of the basicity of amines, that is methyl substituted amines and ethyl substituted amines. Right. So this is what here? Secondary is more basic than primary, then tertiary for methyl substituted. And for this ethyl substituted, secondary is more basic than tertiary than primary. So then ammonia. So all of them are definitely more basic than ammonia here. Right. So this is the basic strength of amines, which can be explained based on all the 3 effects, as inductive effect, solvation effect, and steric hindrance, and not only the inductive effect. So based on the inductive effect, we can decide the basic strength of the amines in the gaseous phase because there is only one effect. But in aqueous phase, the other 2 effects, that is the solvation effect and steric hindrance, should also be taken into account. Yes, in my next video, I'm going to discuss about this, how the basicity of aryl amines when compared to that of the ammonia. Right. So if you like my video, please do like, share, and subscribe my channel. And the whole chapter has been discussed on my YouTube channel, and the details of this has been given in the description box below.